All right, so we're gonna give this new video editing software a run, and I'm gonna do my first kind of review video as I do it. So good luck to me. So the first thing I want to talk about is the structure on the periodic table. This is your periodic table. If you've never seen it before, I'm not quite sure how you got here. You'll see these numbers 1 through 18 going across the top of the periodic table. Right, those are your group numbers. They're also called families. So your first group is the hydrogen family, then you've got the beryllium family, scandium family, titanium family, so on and so forth. That numbering system, that convention can change from periodic table to periodic table, but our vertical columns are called groups or families. Going across the periodic table, we've got periods. There are 7 of them. We've got 1, 2, 3, 4, 5, 6, 7. Okay. Your nonmetals are listed on the left of this staircase. Okay. Your nonmetals are on the right. So your nonmetals are the more purpley colored. Your metals are the red through the green. Certain families have particular names. This family here, the hydrogen family, that first group is called the alkali metals. It took me way longer than it should have. Second group here is called the alkaline earth metals. 7th group, you've got the halogens. 8th group, you've got the noble gases. Okay. One thing to note out, please recognize / remember that your lanthanides tuck in here and your actinides tuck in here. So there are not 9 periods on the periodic table. There are factually 7. Some other things to remember about the organization of the table. This here is my S block. Over here we've got our P block. Here's our D block. And whoops, this is our F block. Okay. Our F block is sometimes called the intertransition metals. Our D block is called the transition metals. Okay. When we're talking about our periods, right, we said we had 1 through 7. That's also our principal energy level number. Our D block, we subtract 1 from N. And our F block, we subtract 2 from N to have the appropriate electron configuration. Okay. So let's kind of hone in on what's actually happening inside the box. So if you've got a box on the periodic table, you typically have a symbol, some sort of whole number, and then some sort of number with fractions or a decimal point. Okay. So this here is our atomic number. It tells us the number of protons an atom has. Okay, and as long as we're talking about electrons, that also then means it tells us the number of electrons that atom has. This here is our atomic mass. It's the weighted average of all the different isotopes of an atom. And if you don't know what isotope is, just kind of hang on, we're getting there. If there's a charge, that means that we have gained or lost electrons. And that normally has to do with position on the periodic table. So if chlorine is going to form an ion, we're going to gain 1 electron to look like the closest noble gas, thereby forming a chlorine 1- ion. Potassium, however, is going to be much closer to argon than it is to krypton, electronically speaking. So it's actually going to lose an electron, thereby making it a potassium +1 ion. You actually don't need reference sheets or anything like that to figure out ion charges. You just really need the periodic table. So the number of electrons is nowhere on the periodic table, other than it being in reference to the number of protons. Another important number to talk about is the mass number. It doesn't appear anywhere on the periodic table, but most often it's the atomic mass just rounded. And this tells you the number of protons plus the number of neutrons, which we don't use all that often, but it may pop up, and it's a good thing to know in terms of figuring out the number of neutrons, because without it, you can't. So a brief review of the subatomic particles. We've got protons and neutrons in the nucleus. Their charges are indicated by those small superscripts. Protons are positive, neutrons are neutral. Electrons go in orbitals surrounding the nucleus. Please remember, they do not orbit the nucleus. They are in orbitals around the nucleus. And those orbitals correspond to these highlighted boxes on the periodic table. So they have S, P, and D, F orbitals. The S orbitals are spherical, P orbitals are dumbbell, D orbitals are flower, and F orbitals are super complex in shape. If you'd like, I can post the reference slide that I used last year to describe those as well. So that's my giant, huge crash course on the periodic table. It's 6 minutes, not terrible. And then hopefully after this, I'll be able to figure out how to tuck a quiz in here. And then we'll be kind of grooving on this whole flipped classroom thing. So with that being said, I'm going to stop the video now, and hopefully magically by the time you see this, there will be a quiz at the end of it. So I will see you in class. Take care.